Okay, yeah, dark matter. It makes sense. There's a lot of other research that actually point to dark matter, but this is one of the ways of showing, yeah, there's got to be something there that we're not seeing. And it's something that an undergrad can figure out using a radio dish.
Okay, so how do
The
you...
whole point, like, how do we see something? Dark matter is invisible. And what comes to the rescue is the hydrogen 21 centimeter line. At Princeton Physics, one of my favorite classes was the undergraduate advanced physics lab, where we actually used the hydrogen 21 centimeter line to map out the Milky Way. There was a radio telescope on the roof of the physics department that we could use to point it at the galactic disk of the Milky Way. And you could actually figure out what part was moving away from us versus moving towards us. That 1420 megahertz would be a little bit red shifted or a little bit blue shifted, depending on where you were looking. And what you could do, I mean, there's a lot of error, right? Because you don't know exactly where you're pointing. It's kind of a, old disc that they were like, okay, let the undergrads, use it for their lab. The frequency resolution is not that great. I remember calculating the rotation curve, which is depending on how far away I am from the galactic center, how fast is the stuff moving? Now, okay, this is not the data that I got. The data that I got had massive error bars and only like 8 data points. But what you could see is that it would rise and then it would plateau. And this is characteristic of dark matter. Vera Rubin, the astronomer, actually used these galactic rotation curves to calculate dark matter, because if you think about it, the farther away you get from a galaxy center, the slower you should be moving.
Right.
Because Newton's laws, inverse square law. Here, the farther you get away, you're still moving at the same rate. The only way this is possible is if there's a bunch of invisible matter that's actually pulling on you, that's creating this gravitational force.
Because you're farther and farther away and your speed has not changed.
Yeah.
Even though it should now be slower because you're farther away from the gravitational center.
Exactly.
So that gravitational force...
must come from
It has to
something.
come from something.
And that's where sort of